Thanks. So, good afternoon, everyone. It's a pleasure to be here and sharing with you some works that we are doing at Plus Atlantic. So, in this presentation, I'm gonna give you an overview of what we have been done so far, and related to the trying to understand the interaction between the atmosphere and the ocean on the marine heat waves phenomena or extremes. So just to give a little bit of context and motivation, I know that we don't have we don't need an extra motivation, but because the project is a huge one, and I think that it's an important one. But for example, for us, that as we are based in Portugal, and Portugal has a huge economic area, so it's quite important for us have some idea what can happen when we have marine heat waves in this region, the impact in social and also ecosystem. So, and obviously for climate, it's a perfect opportunity to address that. So when we start this journey, we start with three simple questions in the dream, let's say. And so we start thinking about the trends of marine heat wave in the area that we are interested in. So we'd like to see how the data could show us what is happening, what we can find there. And another question was about the climate modes. For example, we start asking the effect of North Atlantic oscillation in the marine heat waves. And a third one that it's quite challenging, but still that find the parameters that are very important and should be considered in the identification of marine heat waves. So we start with a very simple basic data sets using SST from ESA CCI, and also for the atmosphere analysis. We consider the area 5 at this moment. We are using this one, and also monthly NAO index. So, and in this case, we decide that time when we start using the climatology, computing climatology using the full period that we have in the data, and also apply the standard methodology, that's the whole day, that one that's standard and well known. So looking at some trends, for example, when we start analyzing, it's clear that we can see that there are some trends related to the frequency, and we will see that in other variables too. And as the area that we are studying is a little bit larger, we decide to analyze by biogeochemical region. So when we see in these plots in this side, we can see these areas are close to Portugal, so it's our main focus area to study. So we see the same behaved regarding to the duration of the events. We also see increasing in marine heat wave events, extreme events, and also in the intensity. We have the same trends, the same effect. And then we start think a little bit about the essential variables. It's quite challenging, and as I said before, we start with the NAO to try to understand the impact of this climate mode. So we separate our experiment in positive and negative phase of NAO to see the impact in the frequency, duration, and intensity. So we compute some composites to see the areas that are common, that can have marine heat wave when we have a positive NAO or a negative NAO. So as we can see, they behave a little bit different. So there are some areas that it's very important during keeping an eye during positive NAO, and another one that is more important, it's more reactive to a negative NAO. And then we start looking into more details about that, including some atmospheric physical variables. And in this case, just as a demonstration, we choose a marine heat wave that happened in 2018. That is a huge one. In this morning, we also had a talk regarding to Baltic. The Baltic effect of the marine heat wave is the same period, or it's almost the same period. It's a long one. So we have the marine heat wave intensity, atmospheric pressure, geopotential, and then other variables, atmospheric variables, net heat flux, wind speed, and also you can see the NAO index. And it's interesting because when we look at this figure, we can see a period, a month with a negative NAO, but most of the period we have positive NAO. So as was expected by the composite and also by the literature, we also have some literature on that. When we have positive NAO, it's the same area.
There's a pointer, a laser pointer, and there's also sleek beneath it. The sleekest line on there.
Okay, thank you so much. It helped me. but okay, so with that, we see some pattern that is quite similar to the area of the marine heat. In all of or most of the atmospheric parameters, for example, in the net heat flux and the wind speed, it's a very good one. So we thought let's have a look in some correlation. Maybe there are something that we could find in the correlation, and let's start with some basic variables like the geopotential and also net heat flux and wind speed. So for the geopotential, we choose a Spearman correlation that is more appropriate to represent nonlinearities in between the fields. So, and in this case, we found here this positive correlation between the marine heat wave and the geopotential. So it's not a huge correlation, but it's considerable. It's also here in this range. So maybe we have a sign here. We did the same for the net heat flux, and we could find the same pattern and the same even in the North Atlantic and also here. We can see, I don't have here, but we have the same correlation for the Baltic and also for the Mediterranean Sea. Also positive, so when we have more, we already know that when we have more radiation, we have more increase the sea surface temperature. And another interesting is related to wind speed. That's quite the opposite. When we have where we got a negative correlation, it means that when we have negative wind speed anomalies, we have the increase in the temperature. So we did the same exercise for negative NAO, and the results looks quite similar. We just go quickly here. So we did the same, choose the same parameters, and compute the same Spearman correlation for this event. And it's a long event too, so we can see the same pattern of the correlations for this event. So here becomes the nightmare. I guess I had here a video, but it's not working for sure. But it's okay, I will try to describe it. Because here, this video was to demonstrate our efforts to identify specific marine heat waves. So we dedicate some effort to clustering these marine heat waves, clustering and labeling them, giving some label to identify, to be easy to identify for further study. And in this case, we consider some filters. In this case, we consider marine heat waves that are connected in space and also in time. And with that, we can apply, for example, another filter to help us to identify really important marine heat waves, like area filters, because now we don't have this, at least I don't know yet if we already have something that address that, because sometimes we have a single pixel identified as a marine heat wave. And we know that a single pixel is difficult to say if there are some effects in the ecosystem or in another in small ecosystems. So we can apply some filters regarding to that. Also analyze multiple heat waves at the same time, occurring at the same time, and estimate a little bit better the impact in the ecosystem and social economy. So I'm reaching the end of this presentation, and with this simple analysis, we've got much more questions. We know we also have some ideas or some things that we should consider, maybe consider, like, for example, other parameters, atmospheric parameters, maybe they should be included when we develop an indicator, for example. Maybe we can put everything together, or at least that one that's more important that we can see from the research that's more effective. We also need to include another climate modes, and we still have some clarification about the atmosphere parameters, the others climate modes, and another thing that we want to see the next step is if that pattern, that atmosphere pattern, is also common in other marine heat waves, independent of the size and the duration. Let's see if we have the same. And for sure, the interaction as the atmosphere is also something. And how can we improve the EUVs in the sense of the dynamic of marine heat waves? So in how can we bring everything together and trying to support in terms of climate adaptation, early warning, that is something that it could be very, very meaningful for the management. So we retained just a pretty picture of our team from Plus Atlantic. So thank you so much. Very quickly. Time for one or two questions.
Thank you. Very interesting. I'm wondering, how do you limit in space the magnetic wave? Because I'm guessing you do the analysis first pixel by pixel,
Yeah.
and then at one point you say if it's more than I don't know certain value, it's a magnetic wave, right?
Yeah.
But then that's purely arbitrary when you decide.
Yeah. Yeah. I totally agree. And this is something that we are looking with carefully, because we want to find some relation, some physical relation that we can use as a threshold to limit an area. It's not only, I guess that is this. No, we are looking for.
Yeah, I believe it's a big challenge given that the spectra in space is continuous.
Yeah.
It's not discontinuity. So any threshold will be kind of artificial, I think. But, but maybe you will find something. So thank you.
Yeah, but less as artificial as possible. Thank you.
Thank you. Thank you very much. So it's really a very nice complete picture on the topic, the very important topic. I just have one question on the aspect of long-term ocean warming versus extremes, and also that related. If you particularly look at the surface, you have specific pattern effect in terms of warming. And also with this question, whether there could be, I don't know, or is the discussion already, I don't know, whether we reach some type of area tipping point, so where the area is going into a kind of permanent marine heat status, or as of course we have that other, the definition of extremes, there are more extreme, etc. So about this discussion, which I think of the interest.
Yeah, we are also, this is a very good question because we are also thinking about it. The few years we got an ocean much more warmer than we have 10 years ago, for example. So it's another challenge that we need to address. We need to find a way to address that.